Today we're going to have some practice with data analysis. And before we can do any of these problems, we have to get familiar with the terms. If we drew a graph here, which is a best fit line, and first of all, we need to talk about what is the actual value or the actual data value. And the actual data value is right here. It's the actual data point. I'll just put the word actual right next to it. We don't know what its coordinates are yet, but that is where the point is. The predicted value is the point directly above it with the same x value on the best fit line. So we'll put predicted just over here, and that's our predicted value. Predicted value is always what the best fit line predicts. The actual value is the actual data point that has been measured. Now the residual, if you remember, is the difference between the actual and predicted, and we wrote that up here. So right over here we say the residual is always equal to the actual value of the data point minus the predicted, and therefore our residual is simply this difference right here where this red line is. And notice, just put the word predicted right there. And notice that when we subtract, we're actually subtracting the y values because the x values are exactly the same. And we'll see that in a minute when we get to our problem. The reason I drew 2 points here is sometimes the actual value could be below the best fit line. Sometimes the actual value could be above the best fit line. If it's above it, then here is the actual value right here. The predicted value is now on the best fit line, but it's below it. And the residual is simply the difference between the actual and the predicted. Now that we have our terms reviewed, let's see if we can do this problem. The question is, find the predicted value if the following is true. The independent variable is 60. Well, that's supposed to be the x value. So let's put 60 in there. And the dependent variable is 90, and the residual is 1.4. First of all, you should notice that if the residual is 1.4, it's positive. That must mean the actual is greater than the predicted, and therefore it would be on the left side of this graph. So we'll say that the independent variable, the x value, is 60 over here. We'll say the dependent variable is 90 over here. And that the residual, this distance between the two, is 1.4. And the question is, find the predicted value. So we certainly know that one thing, that if the x value of the actual is 60, then the x value of the predicted is also 60. But we don't know the y value. But what we do know is that the residual is equal to the actual minus the predicted. So if we write this out here, the residual is equal to the actual y value, which is 90, minus the actual y value of the predicted, which we don't know what it is. So we could call that x. But we do know what the residual is. So we don't have to write the word residual. We simply can just put 1.4. So that's the residual. This is the actual. And this x is our predicted. Well, most of you know how to solve this equation. The easiest, well, a couple of different ways you could do this. I would move x over to the other side. And then I get x plus 1.4 is equal to 90. Subtract 1.4 from both sides. And you get x is equal to 88.6. And this is our predicted value, which is our y coordinate. Probably wasn't a good idea to use the term x because we're talking about our y coordinate here. and we'll just put that right up here, 88.6. And that is our predicted value, 88.6.